Hi friends. Okay, so this is dividing with powers of 10 patterns. So when we're dividing with powers of 10, there will obviously be a pattern if we're using the same number and we change the power of 10. So if you look down here, it says we walk the decimal dog to one place to the left for each exponent or zero, okay? So there's an example right up here of 5 and 328 thousandths divided by 10 to the second power. So the 2 in the exponent told us to move the decimal to the left 2 times. So we're making these numbers smaller when we divide by a power of 10. That's greater than 1. So you're going to jump the 5, and then you have to jump another space. Uh-oh, there wasn't anything there, but we know when you have an empty space, you have to fill it with a 0, right? So that's what she did, and then you can see that the answer right there is 0.5328 10,000ths, or 0.05328. So looking at this little box down here, they've got 143 and 28 hundredths divided by 10 to the second power. They jump that decimal over 2 digits to the left, right? So the decimal ends up between the 1 and the 4, and that's 1 and 4,328 10,000. What's the other one was 100,000. Sorry, sometimes the smarty gets herself confused. So here's a little example of that pattern. We're going to move on, and I'm going to show you some more examples also. Also, you can see in the corner, if there is no decimal, that means it's a whole number, and the decimal is at the end, which we also talked about in our last video. All right, let's go on to our example. Okay, so we've got 34,000 divided by 10, okay? So let's get some annotation going here. All right, so we can see that our power of 10 has 1 0. That means we're gonna move that decimal 1 time. We're gonna skip 1 digit to the left, okay? Well, 34,000, that's a whole number, which means it does have an invisible decimal like we just talked about, and it's right there at the end. So we need to jump it 1 digit to the left. So I'm gonna jump one of those zeros, okay? So that means in my answer, I'm gonna have 34,000.0. But we know that when we have a whole number and all that's behind that decimal is zeros, we can actually get rid of those. We don't need those. So I'll get rid of that, and I don't need that decimal. So that is just 33,400, okay? Now, looking at this one, let's look at our next one. Well, our power of 10 this time has 2 zeros, right? So I'm going to take that invisible decimal that's right there at the end, and I'm going to move it 2 times. I'm going to jump 2 digits to the left. So I'm going to jump this 0 and jump that 0. There we go. So my decimal is going to end up right there in between these 2 zeros, right? So it's going to be 33,400 with 1 0. Then there's the decimal and the 2 zeros that would have been behind it. But we know we don't need zeros behind the decimal. And for a whole number, we also don't really need that decimal. So I'm going to get rid of those. Okay, so that's just 340. Okay, now let's look at this next one. 34,000 divided by 1,000. Well, 1,000 has 3 zeros. Okay, so we're going to take that invisible decimal that's right there at the end, and we're going to move it 3 times. 1, 2, 3. Okay, so it's going to end up right there behind the 4. I've jumped 3 digits to the left. Okay, so my answer is going to be 34.000. All 3 of those zeros ended up behind the decimal, but we know 34 is still a whole number. So I can get rid of all that extra stuff. By, and by, okay? Just the number 34. So this is an example of a number that, like, we didn't necessarily go into the decimals, but this is how you get rid of some of those zeros. You can see we actually just kind of knocked off a 0 each time we divided by a 10, because when we're dealing with whole numbers, we get to do that. There was 1 0 here, so we knocked off 1 0. There were 2 zeros here, so we knocked off 2 zeros. Here, there were 3 zeros, we knocked off 1, 2, 3 zeros. And then we got our answer. Okay, so when we're dealing with whole numbers, you can really just get rid of the zeros. All right, let's look at our next example. We're going to clear these drawings. Okay. Come on. Oh, I get it. All right, now let's look at this one. So we've got 300 divided by 10. Well, we know the trick. Essentially, we're moving that decimal one time to the left, right? Because 10 has 1 0. So either I can move that decimal, that invisible decimal, one time, or I can just knock that 0 off. I know my answer is 30. All right, that's the whole number. This next one, I've got 2 zeros to get rid of. So I can go 1, 2. It's the same thing as taking that decimal and jumping 2 places to the left. It's going to end up behind the 3. So that is just the number 3. Okay. Now let's look at this bottom one. I've got to jump 3 places, right? So I'm going to take that decimal. I'm going to jump 3 places to the left. 1, 2, 3. Uh-oh, it's in front of the 3, okay? So essentially I knocked off those 2 zeros, but I can't knock off the digit. You can't get rid of the digit. That's not how it works. We have to keep that 3. I can get rid of the zeros because we don't need them behind the decimal. But I need to keep the real digit. You can't just knock those off. So I place that decimal first because that's what it said, and I'm putting the 3 behind it. Those 2 zeros would have been there, but we know that we don't need them. If they're behind all of the real digits that aren't 0, then we don't need them. So I can just get rid of those. Bye. And my answer would be 3/10. Okay, so that's how we go from a number that was a whole number, and then you divide by a power of 10 that's so big that it actually turns it into a decimal. Okay, just remember that you can't get rid of real digits. You can't get rid of digits like 3, 4, 5, 1, 7. You can't get rid of those. You can get rid of zeros, but you can't get rid of real digits. Okay? All right, those are our examples. Email me if you have any questions. All right, thanks, friends.